Now I would like to introduce about TF-IDF. What is TF-IDF? TF means term frequency. TF means term frequency. IDF means inverse data frequency. So the term frequency TF, this is the definition here. But if it is too complicated, I will just use this kind of formula. So this formula means I want to know how many of that words divided by the total words that you have in one document or in one sentence. Inverse data frequency or IDF, we want to make the log function, and the log function, it will be the n is the number of document divided by the number of document containing I, and we will have the weight, the TF-IDF score W, which is the multiplication of the frequency with the IDF. So this is the IDF. That's why we call it the TF-IDF, because it is the multiplication of the TF and IDF. So let's see an example. We have the words. The sentence 1 is A and the sentence 2 is B. Let's say that it is a document A and document B. In the document A, we have the word, the car is driven on the road. In the document B, we have the truck is driven on the highway. So using the TF-IDF, I can try to measure the similarity. How can I get this one? First, I need to check the frequency. What is the frequency? The A, document A, have the word the 1, have the word car 1, have the word truck 0, because the truck is in the P. And then we have is 1, driven 1, on 1, the. Why we have this one also 1? This one is using uppercase. This one is using lowercase. So we can make it different. Yeah, for this example, I will make it different, but usually we will make all the letters into the lowercase. So you cannot have like this one. But let me just make it different. Road equals to 1, highway is 0. Okay. For the B, we have this is the term frequency, or we just have the frequency. The car is 0 and road is 0. We want to calculate the TF. TF is the term frequency, which is the ratio. So we have the number appearance of the word, which is 1, and we want to divide it with the number of words that exist in that document. So we have 1, 2, 3, 4, 5, 6, 7. Then the document A, we have 1 over 7. What about the document B? The word the is also 1, and we have 1, 2, 3, 4, 5, 6, 7. Then it is also 1 over 7. What is IDF? The IDF means I have the documents. We have 2 documents. And in those two documents, the word the appear in A and B. So it means it appears two times. So if we have log 2 divided by 2, this is 1, then it is 0. And the TF-IDF, it will be divided into the document A and B. The TF-IDF A is 0, the TF-IDF B is 0. What about the second? Car. The word car appears in the document A. So we have 1 over 7. But it does not appear in the document B. So it is 0. For the IDF, we can say that it is log 2 divided by 1. Log 2 divided by 1. Why? We have two documents, which is A and B. But among those two documents, we have only one document that contains the word heart. So that's why we have log 2 divided by 1. And we have the value 0.2. So in this case, we have 1 over 7 multiply 0.3. We have the value A 0.043. The B is 0. 0 multiplied by 0.3, it is 0. Truck. The word truck is available in the document B, but it is not available in the document A. And yeah, we can calculate like this one. It is 0, it is 1 over 7. And again, for the log, we have two documents. Among the two documents, the word truck appears only in one document. So we have log 2 divided by 1, and the result is 0.2. So we have the TF-IDF of document A is 0, and the TF-IDF of document B is 0.043. If you look at this one, it means we have the value. This value will happen if the word is distinct. Car appears in the A, but not in B. Truck appears in B, but not in A. The same with the road and highway. Road appears in the A, but not in B. Highway appears in B, but not in A. Then we know that this kind of analysis, it will give you a higher number when the word is distinct. If there are many similarity, like this one, then the distance will be smaller or goes to 0. We know that the appears on those documents, so it is 0. Is driven on the, so those are 0 because those words appear in the two documents. So this is one of the popular ways to measure the text similarity. The other thing that we can learn from the text data is using the World Wide Web. www. Whenever you go to the internet, you will write the www. It is huge, widely distributed, and it is global information service center. So it is giving you news, it gives you advertisements, consumer information, financial management, education, government, e-commerce, and etc. they have the hyperlink information. So one website can connect to another website. And we have the access and usage information. For example, how many times you visit this website and how long you visit this website. So those kind of information is available in the www. So we can have a rich sources for data mining. But the challenge is, it is too huge for effective data warehousing and data mining. It is too complex and heterogeneous. There is no standard and no such kind of structure. Whenever we do with the web search engine, the basic idea of the web search engine, like if you search in Google, or if you do search in Naver, or if you do search in other search engine, the basic idea is using the index space. This is the very traditional approach. Search the web, and then index the web page, and then build and store huge keyword-based indexes. So if we have the search engine, and then if it shows a list of results, so it will be indexed. This is index 1, it is index 2, it is index 3, it is index 4, it is index 5, and so on. Actually, this kind of indexing, it helps to locate sets of web pages containing certain keywords. So if I look into the keyword machine learning, then it will show the index like this one, 1, 2, 3, 4, 5. If I look into the keyword data mining, maybe the indexing will be a little bit different. So using the index, okay, the indexing, the deficiency is the topic of any thread may easily contain hundreds of thousands of documents. So if you have a lot of documents in the machine learning, it's very difficult to make the index one by one. And many documents that are highly relevant to a topic may not contain keywords defining them. So when you have the documents, let's say using this kind of machine learning, this kind of machine learning, nowadays they have the keyword machine learning because it is a popular keywords. But maybe some of them, they do not contain of the machine learning. For example, maybe this one is still containing. Okay, this one is still containing the machine learning. So even though we put the machine learning keyword, but maybe some of the word they do not contain machine learning. So it may happen because of the polysemy. So maybe they mention as the machine, not as the machine learning, but machine as the mechanics. So when we deal with the web mining, there are some categories. We can mine the content. The content means, what is the inside of the text. Usage. So how many times the user visit the web page. And the structure. So in our school we have the web page. The hubac.kr is the official, and there are many structures. Let's say you can go to the website and then you can log in, or you can search about the department, or you can search about the calendar academic, okay, or you can search about the school profile and etc. Okay? So they have the web structure. We can also mine that kind of structure. So if it is the content, yeah, we want to find what is the content, whether it is education or it is related to language, and search result mining. General access pattern tracking. So we want to know how many people visit and what time usually people visit the website. Customized users tracking. So if you log in into your ID in the school, what will you do next? Maybe after login, you will check your syllabus. After you check the syllabus, you will check your score. After you check your score, you want to do something else. So we can have the tracing from the website. One of the things in the web is the link structure. Link structure means we want to find authoritative web pages. Retrieving pages that are not only relevant, but also high quality or authoritative on the topic. Usually we call it, this is the hyperlink. Hyperlink can infer the notion of authority. The web consists not only pages, but also hyperlink pointing from one page to another. For example, if you go to our school hub.ac.kr, maybe after you click on this website, they have the information about the nearest hospital that you can visit if you are sick. So they will give you the hyperlink. Or if you are visiting our school, they may give you some list of the attraction nearby the school. Or they also have another kind of hyperlinks about the events nearby the school. So these hyperlinks contain an enormous amount of latent human annotation. So this hyperlink can be different for every domain. A hyperlink pointing to another web page, this can be considered as the author's endorsement of the page. What does it mean? If you look at the website, let's say, yeah, I'm checking, for example, Korean app. So they have the selection. Oh, this is the first, this is the next, this is the next, is this next? So maybe this is not the, oh, I have this one. Yeah, this is the search before. If you can see, there's an advertising, advertising, advertising. So those company, they pay to Google, and Google will comes this result to the user whenever user give the keyword like this. So this is the hyperlink to pointing to another web page when there is an author's endorsement. So if the authors pay, then of course it will be like in the first. So we can try to figure out this kind of hyperlink using the HITS hyperlink induced topic search. So we can explore the interaction between hubs and authoritative pages. For example, I have the website car. You know, car. Right? So this car ranking, because they are the company who wants to know which car is the most popular in the world. So the car rankings can connect to any car brand. Maybe they connect to Ferrari, they connect to Fiat, they connect to Ford, they connect to Honda, they connect to Chrysler, and etc. So we call it, this is the hub, because one link can connect to another specific link, and the specific link is the authorities. So we can find what is the good hub and what is the good authorities. So we can find the weight, hub weight, and we can find the authority weights. If the hub is having a high weight, then it is a good hub. If the hub is having a low weight, then maybe it is not a good hub. This kind of hit system has been applied in Google. Okay, there's one search engine, Clever. Okay. They use this kind of hits to make the search result. We have two update operation. We have V. This is for the authority, and U for the hub. So this is the formula. V equals to A transpose multiplied by U, and then U is a multiplication between the matrix A multiplied by V. Just an example. We have 1 goes to 3, and we have another website 2 goes to 3. So for example, maybe this is website A. There's a link to the website B. And then this is a website C. There's a link to website B. So people who visited A will connect to website B. People who visited C will connect to website B. So we call this is there is an adjacency. Or we can say this is the 1, 2, 3, 1, 2, 3. So 1 to 3 we have 1, 2 to 3 we have 1, and the remaining are 0. After we have this adjacency, we can do the transpose. The transpose matrix is this one. From this matrix, we transpose into this 0, 0, 0, 0, 0, 0, 1, 1, 0. Let's assume we have initial weight U. It is 1, 1, 1. So I have this is 1, I have this is 1, I have this is 1. So based on the formula, V is A transpose multiplied by U. So I can just apply A transpose multiplied by U. Multiplied by U. So this is the authority weight. Authority weight means the number 3 is the authority. And we can compute the hub weight. The hub weight is the U multiplied by A multiplied by V. A is from this one multiplied by V. V is from here. So we can get this is the hub weight. So the hub weight, this hub has the weight 2, this hub has the weight 2, and this authority has the weight 2 as well. Okay, so this is the simple example about its algorithm. Okay, so that's all that we learned in this chapter. We learned about the time series and the text data. Okay, we have still 2 minutes left. You can prepare for the quiz.